What is a logarithm? Well, a logarithm is simply a different way of writing an exponential relationship. So this reads log base b of x is equal to a. This thing right there is always the base. This thing right there is always the exponent. So log base b of x is equal to a. What that means is this. B raised to the a power is equal to x. This raised to that equals that. That's what it means. So let's try a couple examples. It says express the following in exponential form. So log base 2 of 32 is equal to 5. So what number goes for your base? 2 is the base. The exponent is 5, and that equals 32. Do you think you could do that on the test? The next one would be 6 to the second is equal to 36. So, true or false? This is new for most people. True. However, is it really that challenging to rewrite it? No, this is something we can do. 12 to what power is equal to 1? And here, 3 raised to the 5th is equal to 243. We'll get the next ones in a second. Let's look at letter A down here. Now it says express these in logarithmic form. So log, what's the base? The base is 2. Now, sometimes people get confused what to put here. The exponent always goes here. Yep, so the log base 2 of 16 is equal to 4. Logarithms solved for exponents. Log base 10 of 100,000 is equal to 5. Log base 8 of 1/64 is equal to -2. And log base 7 of 1 is equal to all right. Now, let's look at this piece. Suppose you see log of x is equal to a. How is this different than this expression here? There's no base. If you don't see a base listed, the base is assumed to be 10. So it means 10 to what power is equal to x? So, log of 100. 10 to what power is 100? 10 to what power is 100? 2. 10 to what power is a million? Be 6. 10 to the first power is 10. 10 to what power is 10 to the 23rd? 10 to what power is 10 to the 23rd? What would that question mark be? 23. If it's a decimal, it's a negative exponent, right? Tenth would be -1, hundredth would be -2, thousandth would be -3. Now, if I look at my calculator, your calculator has buttons for these. If you notice, it has a logarithm button right here. If I try log, and this is a base 10 of 0.001, I get -3, just like we said. But there's only a log base 10 on here. There's actually a log base e. We'll talk about that in a second. If you see this, this means natural logarithm. What is a natural logarithm? A natural logarithm is this. It's log base e of x is equal to a. If you see ln, that means natural logarithm, and the base is e. What is e? E is a special number. Pi is a number that is approximately 3.141. That's a number that we use. It represents a relationship with circles and other things that we see, in geometry especially. But there's another number, and it's the number e, and it's approximately 2.728, okay? Or 782, excuse me. I can't remember. We'll look it up. I feel embarrassed now. There's an E button right there. We got 718. 718 should have written. So it's a number that comes up in nature. Actually has to do with the way that things grow in nature, the way that things spread. So bacteria, the way that bacteria grows and spreads can be modeled using a letter E. Lots of things in nature can be modeled that way. So let's go to this part right here. You see natural log of e is equal to 1. I won't write this every time, but that means log base e of e is equal to 1. So if you wanted to write that in exponential form, what's the base? E. What's the exponent? 1 is equal to e. Look at the next one. If it's natural log, what's the base? E. What's the exponent? 0. Equals 1. Anything to the 0 power is 1. Okay, let's jump to this one here. I want to look at A, or I want to look at letter B again. We said log base 10 of 100,000 is equal to 5. You don't have to write base 10. You could just write log of 100,000 is equal to 5. Either is acceptable on the test. If you write the base at 10, that's fine. But usually if the base is 10, we just leave it off. We say that's the assumed base. So 10 to the negative 1 is equal to 1/10. Log, what's the base? 10, I don't have to write it, of 1/10 is equal to negative 1. Uh-oh, for f, the base is e. So what should I write? Natural log of e is equal to 1. Not too bad, huh? Let's flip it over and we'll finish with these. Now we want to be able to evaluate some logarithms. This says the log base 4 of 64. So I'm going to put it equal to x. So what I'm trying to answer is 4 to what power is 64? 4 to what power is 64? 4 squared is 16 times 4 more is 64. So it's third power. And you could try that on your calculator until you're able to figure it out. This would be x to the, 3 to the x power is equal to 1/9. So let's think about this. 3 to what power is 9? 3 to the second power is 9. Everybody agreed? So if it's 1/9, the negative 2 power. Just so everybody understands that, 3 squared is 9, but 3 to the negative 2 is the same thing as 1 over 3 squared. We have a negative, that brings us to a fraction. So 3 to what power is 1/9? It's not 2, it's negative 2. Log of 100,000 equals x. That means 10 to what power is 100,000? See, this would be 10 to the 1, 10 to the 2, it's to the 5. Yep, x equals 5. This one looks tricky, but it's not bad. This is equal to x, so it means 5 to the x power is equal to 5 to the third. What number would be where x goes? 3. Again, this is x. So what's the base if it's natural log? E to the x power is equal to e. What power would you take e to get e? 1. And again, we have natural log, so the base is e. E to the x power is equal to 1 over e squared. Suppose it was e to what power is e squared. Suppose it wasn't 1 over. Suppose it was e to what power is e squared. There would be 2, right? So if it's 1 over, then it will be negative 2. If it's in the denominator, we make it negative. Anybody feel like that doesn't always just like work real good with their brain? Your brain's wired to work really well with addition and with multiplication, but it's not wired to work well all the time with subtraction, division, logarithms, things like that. And so don't feel bad if that doesn't work right away. Okay. All right, we end with these 4 problems here. Okay. Now it says find x. Look at how x is in a different spot now. So we say 2, what's the exponent? Is equal to x. X is 8. 2 times 2 is 4, times 2 more is 8. Log base x of 100 is 2. So that means x to the second power is equal to 100. X is 10. Five to the x power is 125. X is 3. And finally, 10 to the negative 3 power is equal to x. What's 10 to the third? 10 times 10 is 100, times 10 more is 1,000. So if it's negative 3, that would be 1 over 1,000. And that's that. If you turn to your worksheet, your worksheet will fall very similar to how we just did it. You can do section 1, 2, and 3. And on the back side, you can also do a 4. And I'll be working on producing those answer keys. On Monday, you'll have a study guide that we'll go over to kind of together, because there's a lot of things from this unit that are a little bit new. And hopefully, if we follow on and put forth effort, you should do just fine. So you have the rest of the time to work. Good job.